Dear student, today we are discussing the 11th level chapter and the chapter name is trigonometrical identities. Trigonometrical identities. In this chapter, at first we are discussing some formula and then give some example of this chapter. We are divide the formula of this chapter in three types. The types are when a plus b plus c is equal to pi, that is a 180 degree. Then we can find the three types of formula. One kind is sin theta type formula, and second is cos theta type formula, and third is tan theta type formula. We are giving the formula of sin type formula, cos type formula, tan type formula one by one. After completing the formula, we are discussing some example of this chapter. Now at first we are giving the sin theta type formula for the a plus b plus c is equal to 180 degree. Now first formula is sin of 2a plus sin of 2b plus sin of 2c is equal to 4 times of sin a, sin b, sin c. Similarly, the second formula is sin of a plus sin of b plus sin of c is equal to 4 times of cos of a by 2 into cos of b by 2 into cos of c by 2. And the third formula is sin of a by 2 plus sin of b by 2 plus sin of c by 2 is equal to 1 plus 4 sin pi minus a by 4 multiple with sin pi minus b by 4 multiple with sin pi minus c by 4. And the fourth formula sin square a plus sin square b plus sin square c is equal to 2 times of 1 plus cos a into cos b into cos c. And the last formula of this section is sin square a by 2 plus sin square b by 2 plus sin square c by 2 is equal to 1 minus 2 times of sin a by 2 multiple with sin b by 2 multiple with sin c by 2. This is the first kind formula, that is a sin type formula, this 5. And now we move to the next type, that is a cos type formula. Now the next, that is the cos type identities or formula we are discussing here. Now there are also 5 formula of cos type, cos theta type. Now the first identities or formula is we are using here cos of 2a plus cos of 2b plus cos of 2c is equal to minus 4 cos a cos b cos c minus of 1. And second formula cos a plus cos b plus cos c is equal to 1 plus 4 times of sin a by 2 into sin b by 2 into sin c by 2. And the third formula is cos of a by 2 plus cos of b by 2 plus cos of c by 2 is equal to 4 times of cos b plus c by 4 multiple with cos c plus a by 4 multiple with cos a plus b by 4. And now the fourth identity of cos theta type is cos square a plus cos square b plus of cos square c is equal to 2 times of 1 plus sin a into sin b into sin c. And now the last identities or formula of cos theta type is cos square a by 2 plus cos square b by 2 minus of there is a difference minus of cos square c by 2 is equal to 2 times of cos a by 2 into cos b by 2 into sin c by 2. Now we move to the next, that is the tan theta type formula of this chapter. We are discussing the tan theta type identities of this chapter, that is the trigonometrical identities. First identities is tan of a plus tan of b plus tan of c is equal to tan a into tan b into tan c. And the second identities of tan theta type is tan a by 2 multiple with tan b by 2 plus tan b by 2 into tan c by 2 plus tan c by 2 multiple with tan a by 2 is equal to 1. This is a sin theta, cos theta and tan theta type identities for this chapter, which are used to solve the problem of this chapter. Now we move to the next part, that is the example part. Now this is the first example of the day, and the example is, if sin A plus sin B plus sin C is equal to 0, then show that sin of 3A plus sin of 3B plus sin of 3C is equal to minus 12 times of sin A into sin B into sin C. Now according to given information we can write, so LHS is equal to sin of 3A plus sin of 3B plus sin of 3C. And now we are using the formula of sin 3 theta type formula. We get this for first part, we get this for the second part, we get this for the third part. And now we are taking 3 sin A, 3 sin B, 3 sin C is at a times and 3 is uncommon. These 3, this one and this one take here and take the common of 3, and similarly this one and that one take here and common of minus 4. Now by the given condition, sin of A plus sin of B plus sin of C is equal to 0. So we are using here, and since sin of A plus sin of B plus sin of C is 0, then we can say AQ plus BQ plus CQ type formula is equal to 0 plus 3ABC, since A plus B plus C is equal to 0. That is, if we compare A is equal to sin of A, B is equal to sin of B and C is equal to sin of C, then we get this one. So we are putting here 0 plus 3, 0 plus 3, A that is the sin of A, B that is the sin of B, C that is the sin of C. Now multiplying 4 we get these lines, and now after these are the 0, so this will be the vanish, and minus of 12 sin A, sin B, sin C is there, which is our required result. Dear student, subscribe the channel for more informations. And now we move to the next, that is the last example of the day. Now we are discussing the last example of the day. If A plus B plus C is equal to pi and alpha is equal to 5 pi plus A divided by 2 to the power 5, and beta is equal to 5 pi plus B divided by 2 to the power 5, and gamma is equal to 5 pi plus C divided by 2 to the power 5, then show that cot of alpha plus cot of beta plus cot of gamma is equal to cot alpha into cot beta into cot gamma. We are starting from alpha plus beta plus gamma, and putting out the value of alpha and the value of beta and the value of gamma, and calculating we get 5 pi plus A plus 5 pi plus B plus 5 pi plus C divided with 2 to the power 5, and calculating 5 pi is equal to 15 pi plus of A plus B plus C, A plus B plus C divided by 2 to the power 5 is equal to 32. And now we know that by the given condition A plus B plus C is equal to pi, so we are putting here A plus B plus C is equal to pi, then 15 pi plus of pi is equal to 16 pi, and divided with 32, that is the 16 pi divided by 32 is equal to pi by 2. So plus beta plus gamma is equal to pi by 2. If we shift gamma in the right side, then we get alpha plus beta is equal to pi by 2 minus of gamma. Taking cot both sides, we get cot of alpha plus beta is equal to cot of pi by 2 minus of gamma, and we know that cot of 90 minus theta is equal to tan theta. Now using the formula of cot of alpha plus beta, that is we get cot of alpha into cot of beta minus of 1 divided by cot of alpha plus cot of beta, and this will be tan of gamma is equal to 1 by cot of gamma. So after multiplying, cross multiplying, we get cot of alpha cot of beta, cot of gamma minus of cot gamma is equal to cot of alpha plus cot of beta. So cot of alpha, cot of beta, cot of gamma is equal to cot alpha, cot beta, cot gamma, which is our required result. Hope the given information and the example of this chapter will help you to understand this chapter when we practicing this chapter in later, and this video will enrich your knowledge and help you to solve the problem of this chapter.